So hello and welcome my dear student in my channel A Journey with Physics where quality matters. So today we have come again another session from HC Verma solution, and today we'll discuss from question number 8, that is from question number 12 and question number 13 will be discussed in this session. And what we are doing is that we are trying to solve the HC Verma solution from electric currents in conductors, the chapter from page number that is of 198. There are so many part has been uploaded, so you can check my playlist or you can visit the description box, which and then you can find the link given below. So let's start for today's session. And before actually start, so hi, this is Sujit to take today's class with you. So first question of the day, that is of question number 12. What does the question say? Look at the question in the screen on your, that is calculate the electric field in a copper wire of cross-sectional area of 2 mm square and carrying a current of 1 ampere, and the resistivity of the copper is 1.7 into 10 to the power minus 8 ohm meter. So question says the current flowing through the conductor wire is of 1 ampere and the cross-sectional area that is of 2.0 mm square. That means you can convert this 2 mm into meter square, and it looks like that. And you have to find out the electric field that is of E, and given data is, another data is there. So another data is that is of rho, resistivity rho is there. So the value of the rho is 1.7 into 10 to the power minus 8. 1.7 into 10 to the power minus of 8 ohm meter. This is the value of resistivity. Now you can think how you can solve it. So you know our formula very much well. That is the relation J equals to sigma A. That is the vector form of Ohm's law. That is a vector form of Ohm's law. The J equals to sigma A. Now you can convert J, that is I by A, and sigma can be written as 1 by rho, and E is there. So according to relation, that is sigma, that is of conductivity, and the resistivity is of proportion, that is of inverse relation. They have a relation between these two things at inverse relation. So sigma can be written as 1 by rho, and J, that is the current density, can be written as the current by cross-sectional area, stick upon cross-sectional area. So now electric field can be written as so I by A into rho, I by A into rho. Now put the value of all you know. I1 A 2 into 10 to the power minus 6, and value of rho is 1.7 into 10 to the power of minus of 8. So if you check and if you do this, the relation, and if you do this calculation, so 1.7 by 2 into 10 to the power minus 2. So 1.7 by 2, so etake, so you can remove this decimal and you can take 10 is the denominator part, that is of 17 by 2 and 10 to the power minus of 3, that is of 8.5 into 10 to the power minus of 3, that is of volt per meter. So this is the value of the electric field, and the value is the 8.5 into 10 to the power minus 3. This is the volt per meter. So this is how we can solve the electric field from the given data. So this is very much important, and you know the H.C. Verma is a very important book for your growing in concept in physics. Okay, and so not only in concept but also, so this book can help you in cracking WBJE, that is of NEET, JEE Main. So very much essential for the various exam. So that is why we are planning so to give you the H.C. Verma solution at every day, every alternative day, and you will find the every alternative day the solution from H.C. Verma on the basis of class 11 and the basis of class 12. So actually we know that. Now moving to the next question. So the question number 13, and the session will be very much short. And question number 13, what are the question number 13 says? Just look. So look at your screen. What the question says: a wire has a length of 2 meter and the resistance of 5 ohm. Find the electric field existing inside the wire if it carries a current of 10 ampere. Again, you have to find the electric field, but the given data is another form. So I is 10 ampere and the wire length is 2 meter. Wire length L is 2 meter, 2.0 meter, and the resistance is 5 ohm. Resistance is 5.0 ohm, and you have to find the existing electric field. Again, the question on the basis of electric field. Now, how you can solve this? Very easy. So very easy. You know the relation of Ohm's law, the traditional relation, that is the V equals to IR. So in the last math, you have to find out the electric field from the Ohm's law, but in the vector form. But again, you have to find out the electric field in the in this question. Again, you have to remember the Ohm. You have to remember the Ohm and the famous Ohm's law, that is the in traditional form, that is a V equals to IR. Okay, so you can write V as E into L, because you know the relation V E equals to V by R, that is electric field equals to potential upon distance. So potential can be written as E cross R, that is E into L. So length of the wire and the electric field existing between the two ends of the wire, and now you can written in the right side as well as it was before, that is I into R. So now you can find electric field E, that is I into R by of L, and you can put the value of everything, that is of 10, that is of 5, and L 2. L, the value of L is 2, and the value of R is 5, and the value of I is 10. Yes. So now you can, so 50, and that is of 25. So you can write, that is of electric field. Sorry, it is not the meter, it is as volt per meter. So electric field 25 volt per meter, or you can write Newton per coulomb. So both the unit is valid. Okay, both the unit is valid. So okay, so today's session is of 10 minutes and we have solved the 2 problems, and we are going as our plan, that is every alternative day we are doing H.C. Verma, or we are doing the solution of from H.C. Verma book, and in this way I hope we can solve the rest of the solution from each and every chapter. So I will end up today's session here, and we will come in front of you in another day and again with another session and the session will be very much fruitful for you.